And now the moment you've all been waiting for, the fundamental theorem of calculus part 2. Hey, we've already done this one. It's where you take the capital F derivative function of b minus capital F of a, which is equal to the integral from a to b of fx dx. We've done this, but it's actually part of the fundamental theorem of calculus. It's the second part of the fundamental theorem of calculus. And it's a way for us to solve an integral out, a definite integral, by undoing what's being done. It's really kind of cool, and we've done it several times, but here we go. Let's just do another problem because, hey, what else are we going to do? So I've got this guy right here, and we're going from -1 to 3 of x cubed plus 1 dx. Now, we could look at this as two separate functions, but I like to look at it kind of as one. It's a little bit easier and less messy. So here we go. If y prime is equal to x cubed plus 1, y is equal to what? Well, remember when you take derivative, you subtract 1 from the exponent, okay? So if I have x cubed as my derivative, I had to start at x to the 4th, all right? And right here I have x to the 0 as a derivative, so I had to start with x to the 1st. Now, just ask yourself, 4 times what number is 1? Because that's what I have right here. So that's got to be 4 times 1/4. And 1 times what number is 1? Well, that would be 1. Okay. So this guy right here is capital F of x. This guy right here is little f of x. So what we're doing is we're evaluating the integral by finding the antiderivative of little f of x. And now what do we do? Well, now we take this 1/4 x to the, whoa, that's not the color I want. Hold on. Now we take this 1/4 x to the 4th plus x, and we evaluate it from -1 to 3. And what's the evaluate part? That's this guy right here. We're going to do the function where we stop minus the function where we start. So where do we stop? We stop at 3. So this is going to be 1/4 times 3 to the 4th plus x minus the function where we started. 1/4 times -1 to the 4th plus -1. Okay? So it's the function where we stop minus the function where we start. And we just simplify all this out and we'll have ourselves an answer. So I've got 81, 3 to the 4th is 81. So this is 81 over 4. This guy right here that I wrote down as x is really not x. I was just tricking you. So let's get rid of the trick. That should be a 3. So 81 plus 3 minus, what's going on here? 1/4 times 1, 1/4 minus 1. Okay, so this is what we've got, and you can put all this together into one. You can punch it in your calculator. You can reduce your fractions. You can do whatever. But this is basically going to be 3 plus 1, okay, which is 4. And 81/4 minus 1/4, which is 80/4, which is 24. How cool is that? And the other thing that you could do is punch this into your calculator, and there's 2 different ways to do that, or 3, a myriad, there's thousands, okay? I'm going to show you 3 different ways that you can punch it into your calculator. I'll do that on the next clip, and you can see what happens depending on which calculator you've got or how you want to mess with it. There's some you got some choice, okay? So with that said, that's fundamental theorem of calculus part 2, and it really is super handy.